Let's see. Hello, try. Is everybody okay? Are we all on the same page? Is it audible now? Because I think I now know why it wasn't coming. So now it should be working. Hello. All right. Good. Good. If you can all hear me now, then that's perfect. That's better. So, all right. So give me 1 minute. Okay. So we are going to look at one of the data mining techniques that is referred to as the instant based learning or KNN. Okay, guys. So, like I said, we are going to be dealing with one of the most used algorithms in classification, that is KNN. Am I audible? Can you hear? Can you hear? If you can hear, just say yes. I think I went off, so I need to know if you can all hear me. All right, good. Then we are back to in action. So we are going to be going through KNN. I'm going to explain the concept, and I wouldn't last long today because, like I said, I'm not really feeling well. But I'll give you the basic concept, and I'll give you an assignment to perform using Python, and then so that will be an assignment. I'll try and give you a sample code for that as well in the class group, and then you can and then and then we you can program that so that when we meet next time I would inspect that. I've already given you two, I think two or three different um coding work. When we resume face to face, I'm going to check them. So as much as possible, please try and then get acquainted to it. So now the concept of KNN is very simple. So the basic idea is that if it talks like a duck, quack like a duck, then probably it's a duck. That's what KNN means. So KNN, we train a set of data, and then we use a mean to determine how close it looks like the other object, and then if it does in proximity, then of course it is. Basically, that's it. And process repeat until it gets to a point where it exhausts everything, and then it's able to classify or cluster objects into one characteristics. So you have a training record right inside the, what do you call it, the circle, and the training record. Someone sent a message on Telegram. Let me check what it is. Please, which link? Oh, can you please tell me he's late? The link is already on a group. So you see that in a circle there are training records that is put there, and the training records constitute several objects. So what happens is that we compare the various training records to our test record, right? So we compute the distance between the training records and then our test records using mostly the Euclidean um, algorithm. And then once we train, we realize that okay, the ones below, right? We choose k of the nearest what record. So the number which is near to the record we want to test. Right. Once we choose that, we assign that, then we say that, oh, okay, then it's this because it's very close to that. So we say that a test of label records, right? And then we have the proximity metrics to compute the distance between a pair of records. So we're looking at how close it is in likeness, how close it is to that particular object using the Euclidean distance. Now, the value k is the number of nearest neighbor to what retrieve. And so a method for using the label of k nearest neighbor is to determine the class label of unknown records by taking majority vote. So we look for those that are very close to that. And once we compute the Euclidean in computing, then we keep changing the k value until it gets to a point that we've exhausted our test records, and whatever we are comparing with, we already know where they belong to. Now, the major take the majority vote of class label among the KNN or the k nearest neighbor, then the weight the vote according to the distance. So the calculation, as you see, is W equals to 1 over D squared. So for document, um, quotient is better than coloration of what? The Euclidean. So when we compare this, that's 111110. That's a binary versus the other ones. Which one is closer to the other? All right. So the Euclidean distance is 1.411 for both pairs, but the cosine similarity measure has different values for these pair. So that's why we are saying that instead of using the Euclidean um, method, the the cosine value usually works better than the Euclidean distance. So in data pre-processing is often required. So here we look at attribute may have to be scaled to prevent distance measure from being dominated by one of the attributed. So, example is there. Height of a person may vary from 1.5 meters to 1.8 meters. The weight of a person may vary from 900 90 pounds to 300 pounds. Income of person may vary from $10,000 to $1 million. And so that's why we need to check and make sure that we are picking a K value that is pretty much in a good range. Time series analysis or time series are often standardized to have zero mean, means a standard deviation of what? One. So choosing the K value, here is where, so if your K is too small, sensitivity to noise becomes eminent. And when it's too large, neighborhood may include point from other class. So when you're looking at the similarities, you remember, and so let's say we are dealing with fish and we are picking our K value. If you have red fish, cassava fish, tilapia, clownfish, etc. When you choose a very large K value, it will practically classify all of them as one because all of them seems to have scaled, faint, pictorial, which are similar. And when you pick a very small value too, it's kind of too sensitive that it's not even picking and giving it the appropriate uh, classification. All right. So we always vary our or get a K value that is quite in the middle and somewhat satisfy both almost all so that we are not getting it being too sensitive or overstepping its boundary. All right. So the nearest neighborhood classification are local classification, and they can produce decision boundaries of arbitrary shape. So one NN decision boundary is a Vernier diagram. So here we have a diagram that is depicting a one nearness. So using one as the K value, right? And it's trying to divide the various the graph into various sector. So question is how to handle missing values in training and test. Set. Now proximity computation normally requires the presence of all attributes. So some approaches use the subset of attribute present in two instances. This may not produce good results since it effectively uses different proximity measures for each pair of instance. Thus, proximities are not comparable. And then we have handling irrelevant and then redundant data. So when it comes to attributes, add noise to these add noise. Irrelevant, they always add noise to the proximity measure. And then redundant, which is repetition, attributes are seen as bias because when we have more of those, then it means that the entire computation is skewed towards one area or one classification. Yeah, so here is how handling attributes that are what interacting. So we have our y and x value, and you notice that there are different classes that are put in a graph to help. So avoid having to compute. So these are some of the things we do to improve the efficacy or the outcome of the KNN efficiency. One, we avoid having to compute distance to all objects in the training set. Means you don't have to try and get almost everything done. Else you're going to have problems when you're competing with the what do you call it? test data. So multi-dimensional access method, which is the KD tree. Fast approximate similarity search, and then also the local sensitivity hashing. Again, condensing. Determine a small set of objects that give the same performance. And then editing, that is remove objects to improve what? Efficiency. So that is the basic concept. Now, this is what I want you guys to do. I want you to take the concept of how to improve KNN efficiency. I think the note I'll give you, I'll send you this one. I want you to go through and then write, explain the various stated principle. That is the um, multidimensional, the fast approximating similarity search, and then the locally. Then you also do condense and editing. Um, right? Do I say note on it? Right? Notes on it, and then um, give me your on the and it be should be maximum 2 pages. 2 pages. Then the other assignment would be using Python codes. You can go to Kaggle. I'll send you the link. Get data sets from Kaggle, and then perform a KNN um, procedure with Python on it, and then submit your data. So you would show your data set, and then you show what you got, and then explain it. Now, so that's going to be that. If there's any question, please let me know. I need to go to the hospital. So, is there any question? Okay, so if there is no question, then I think I can end this section now, and then I would uh, I would send the rest of the work to you on the Telegram platform, and then we continue from there. This was just an introductory to so the rest you'd read and then write me some notes. I've seen some people complain that they can't comment. I don't know why they can't comment, but that is life. All right. So see you I believe tomorrow we have a class. So see you tomorrow. Also, I think on virtual. Bye bye.